Hi everybody, welcome back to the TETRIX RoboBench video series. This is Tim, and we are again working our way through the Pulse Programming Guide, Getting Started Activities. We've done 1, 2, 3, and 4. We're ready for the last activity in the Getting Started Activities, which is using the ultrasonic sensor. So, I've got everything that I need here. I've got my computer with my software, battery, charge, ready to go, pulse controller, USB cable, and my ultrasonic sensor with the cable. So we're ready to jump right into our software. We can go into our example menu option, go to Getting Started Activity number 5, and I can open up my example. You see that it brings everything I need into my programming environment. One of the features that we have in the software, we've got this little plus minus that we can actually expand or make things a little bit smaller so they fit on our screen. So I'm going to hit that little minus button, make it show up where I can see everything that I need. Let's look at our program. So we have our little setup block that gives us the framework or structure of our program. We have our pulse begin in that block. Then we have the same logic block that we use for our line finder sensor. We have an if, else if state logic statement that looks at the condition of the ultrasonic sensor that's in our D3 digital input, and it is going to measure centimeters. So that the ultrasonic sensor is going to send a sound wave out. It's going to measure the time that it takes for that to bounce back at me, and then it's going to then know the distance because we know how fast sound travels. So that becomes then a distance finder sensor for us. And we're going to look at that. We're going to compare it to 10 centimeters. And if it is greater than 10, we're going to turn our red light off and actually turn our yellow light on. But if it is less than 10, then we're going to turn our red light on and our yellow light off. That's what should happen. So let's go ahead and let's make our connections. We're going to plug our battery in below our on-off switch, again with the black wire facing to the outside. We're going to put our input into our D3, which should be this one right here in the middle. And we're going to make our connection to our computer with our USB cable. Right like this. And once I have everything connected all up, I'm going to power on my controller so that I've got my blue light showing me that I've got power. We're going to now go ahead and upload our program to the Arduino. I'll click on my little yellow button there, or orange button. It's going to wait for a signal. Data is transmitting, and I should get a message that it says successful. Should have a green light down here, the same that it's ready to go. Now I'm going to press my green button, and I should have a yellow light because it is greater than 10 centimeters. Now as I move my hand down towards the ultrasonic, when I get within 10 centimeters or less, I should have a red light. So as I move back and forth like this, I should get a yellow and red light. I can't see if that's happening, but it looks like it should be. So if I go down, I'm red, up, I'm yellow, down, I'm red, up, I'm yellow. So that's telling me that the sensor is reading correctly, and when I'm getting within prescribed distances, it's reacting to the feedback and turning on or turning off the lights. So that is how you would use the ultrasonic sensor. So let's talk about real world. Smart cars now are using sensors like this, like the ultrasonic, to be able to do things like park themselves or brake if something goes in front of them, or follow a correct distance behind, and cruise control, smart cruise control. So there's a very real world type of connection with automobiles, especially in this kind of environment, that potentially you might have these on your cars at home. So that would be an example of how you would use and program a sensor like that to react to, create a behavior that it react to. And again, for an extension, you could add that to what we already know, because we've got motors that we moved, we've got servos that we can move, and we could add that into our program and create a situation where, based on the distance, and we could change the distance in our program and have it react at different distances or do different output behaviors. So that would be the extension that where you would take this to the next step. So that's activity 5. So I hope you had fun doing 1 through 5 and got a pretty good feel for how this software works with the hardware. We're getting ready now to do the rest of the 10 activities, but we need to build a bot. I'm going to build a bot. Tammy's going to come back and join me, and we're going to do the remaining parts of the activities. So come back and see us.